multiple choice questions on sets, relation and function. Number 1, if A is equal to A, B, C, that is set A contains three elements, and the R set R is equal to A, B, B, C, C and AB, AB is a relation on A, then R is not reflexive, symmetric, option B, this is option B, this is option A, C transitive, and number D equivalence relation. Now here now we can observe that each element of set A is related to itself, and therefore R is a reflexive relation, and therefore the first option is not correct. Again, A related to B, but B does not related to A, that is AB lie in set R, but BA does not belongs in set R, and therefore this is not symmetric relation, so this is not a correct option. Again, now since it is not symmetric, therefore it is not an equivalence relation. Now we want to check whether it is transitive. Now we want to check only these two pair, AA. Now AA lie in set R and AB also lie in set R. So A related to A and A related to B. This implies A is also related to B, and therefore this relation is transitive relation, and therefore correct option is what? Transitive. Now question number 2, if tilde is an equivalence relation, on set X, and for xy from set X, if x bar and y bar denote equivalence classes of x and y respectively, denote equivalence classes of x and y respectively with respect to equivalence relation, say tilde, then the correct option is we want to check number first, A, x bar is equal to y bar if and only if x belongs in y bar. B, x bar is equal to y bar if and if x is equal to y. Number C, x bar is equal to y bar, x bar is not equal to y bar if x belongs to y bar, and number D, none. So here x bar is equal to y bar, does not imply x is equal to y. For example, if we take a simple relation, say here A related to B, if and only say here 3 divides A minus B. Under this relation, the equivalence class of 0 bar is same as 3 bar, but 0 does not equal to 3. So this option is not correct. Again, we know that if x bar equal to y bar, then x belongs in y bar, So this option is not correct. So correct option is what? X bar is equal to y bar. If any two equivalence classes x bar is equal to y bar, then either x belongs to y bar or y belongs in x bar. Okay, so the correct option is what? Option number A. So next, for example, if you take the simple example here, x related to y, if and only if 3 divides x minus y, then here 0 bar is equal to 0 minus 3 plus 3 minus 6 plus 6 minus 9 plus 9 and so on, where x and y are integers. Then here the 0 bar is same as 3 bar, since 0 lie in 3 bar or 3 lie in 0 bar, set 0 bar. Okay, so the correct option is what? A, option number A. Now the next question number 3. Let x denote the set of people living in India. X is equal to set of all people living in India. And for xy belongs to x, for xy belongs in set x, we define the relation, define a relation x related to y if and only if x and y live within 100 kilometers, distance from each other, then the relation tilde is number A, not transitive, option number B, not symmetric, number C, not reflexive, D, equivalence relation. So here the relation is equivalence relation. The relation is given x related to y if and only if x and y live in, that is the distance of x and y less than or equal to what? 100. So we want to check whether it is a reflexive relation. Yes, it is a reflexive relation. Why? Because the distance between x and x is equal to 0 and which is less than or equal to 100, and therefore x related to x for every x in set x, from set x, therefore it is a reflexive, and therefore this is a wrong option. Then whether it is a symmetric, yes, it is also symmetric relation. It is also symmetric because since if the distance between x and y is less than or equal to 100, then the distance between y and x is also less than or equal to 100, and therefore this is symmetric. So therefore this is also not a correct option. Not transitive. Now if the distance between x and y is less than or equal to 100 and distance between y and z is also less than or equal to 100, then it is not necessary that, then for example, if distance of xy is equal to, take say 90, and distance of yz take 80, then what is the distance between xz? This is what, x and y live in 90 kilometer from each other, and y and z lives 80 kilometers from each other. So total distance is what? 170 kilometer, and therefore x is not related to z, and therefore the given relation is not transitive. So the correct option is what? Option number A. Now the next example, number 5. if x bar and y bar denote equivalence classes, if x bar and y bar denote equivalence classes with respect to the equivalence relation, with respect to equivalence relation tilde on set x, then number 1, x bar intersection y bar is equal to empty set. Number B, x bar is equal to y bar. Number C, either x bar intersection y bar is equal to empty set, or x bar is equal to y bar. And number D, none of these. So now if x bar y bar denote the any equivalence classes with respect to the equivalence relation tilde, then this is also true that x bar y bar may be a disjoint set, or maybe x bar is equal to y bar. So the correct option is what? Either x bar intersection y bar is equal to empty set, or x bar is equal to y bar. For example, if we take the relation on set of positive integers and a related to b, if and only if 3 divides a minus b, then the equivalence class of 0 bar is 0, 3, minus 3, 6, minus 6, 9, minus 9, and so on. And the equivalence class of 1 is equal to minus 1, then 2, then 4, because 4 minus 1 is 3, then minus 2 minus 1 is minus 3, then next is what? 7 minus 1 is 6, then minus 5, then 10, minus 8, and so on. So here 0 bar is not equal to 0 bar and 1 bar, two distinct equivalence classes. So 0 bar intersection 1 bar is equal to empty set. And if we take here 3 bar, which is 0 bar is same as 3 bar, so either if we take any two elements, either their intersection is equal to empty set, or they may be equal set. So correct option is what? Option number C. Now take the next example. Example number 6, 5. Let f is a function from minus pi by 2 to pi by 2 to r, set of real number, be a function defined as f of x is equal to sin x, then f is number 1 injective, number B it is surjective, number C bijective, and number D none. So when we said it is a injective function, if f of x is equal to f of y, implies x is equal to y, then we can say that, or x is equal to y, then f of x is equal to f of y, or f of x is not equal to f of y, then x is not equal to y. This is the definition of injective function. So now from minus pi by 2 to pi by 2, we want to check whether it is injective or not. So now if we draw the graph of the given function between minus pi by 2 to plus pi by 2, here it is minus pi by 2 to plus pi by 2, and the graph of sin x is, this is the graph of, here it is 1 and here it is minus 1, and if we draw the horizontal line here, it intersects the given graph at only one point, and therefore x is equal to, f of x is equal to f of y implies x is equal to y, or f of x is not equal to f of y, then x is not equal to y, condition satisfy. Again, it is not a this is not a bijective function, a surjective function, because this is not an onto function here, because there does not exist x such that f of x is equal to what, 10, because what is the range of the sin x? It is lie between, the sin x is always lie between -1 less than or equal to sin x less than or equal to 1. So there does not exist x such that f of x is equal to 10. Therefore it is not a surjective function, but it is a one function. Again, it is not a bijective function. So this option and this option is not correct. The correct option is what? It is an injective function. So the next example, now on question number 7, let f is a function from 0 to pi, close interval 0 pi to r is a function defined as f of x is equal to sin x plus cos x, then number A, under root of 2 lie in range of f. Number 2, under root of 2 does not belongs in range set of A, it belongs to range of f. Number A, B, C, 1 does not belongs to range of f, and number D, none. -1 does not belongs to range of f. So the given function is what? F of x is equal to sin x plus cos x. F of x is equal to sin x plus cos x. We know that if the f of pi by 4, since pi by 4 lie in 0 to pi, so f of pi by 4 is equal to sin pi by 4, that is 1 by root 2 plus 1 by root 2, which is equal to under root of 2, which is 2 divided by under root of 2, that is here it is 2 divided by under root of 2, so it is under root of 2, and under root of 2 lie in range set of f, and therefore that is there exists x, that is pi by 4, so that f of pi by 4 is equal to root 2, and therefore the root 2 lie in range of set of f is correct option. Again, this is false option. 1 does not belongs to range of f. It is false because if we take here, if we take the simple say f of 0, then f of 0 is what, 1. So 1 belongs to range of f. So this option is false. -1. So if we take here f of pi by 4 pi, then sin pi is 0 and cos pi is 1. So -1 is also lie in a range of f, and therefore all this option is also what, a wrong option. So correct option is what, under root 2 lie in range set of f for the given function. Now the next example number 8, a function f is defined from r to r, defined as f of x is equal to twice x plus 3 divided by 5. Then first A is f is injective, f is not injective, B, f is not surjective, C, f is bijective, it is bijective, and number D, none. So the given function f of x is equal to twice x plus 3 divided by 5. So if we consider f of x is equal to f of y, suppose f of x is equal to f of y, then twice x plus 3 divided by 5 is equal to twice y plus 3 divided by 5. So this implies this 5 will get cancelled here. Twice x plus 3 is equal to twice y plus 3. So this 3 will get cancelled here, and this implies twice x is equal to twice y. This implies x is equal to y, and therefore f of x is equal to f of y implies x is equal to y, and therefore this function is what, injective, and therefore this is not a correct option. So f is not surjective. Again, if we interchange given, if we replace, take f of x is equal to y, which is equal to twice x plus 3 divided by 5, and if we interchange x and y, then x is equal to twice y plus 3 divided by 5, then the twice y plus 3 is equal to 5x, and twice y is equal to 5x minus 3, and this implies y is equal to what? 5x minus 3 divided by 2. So this is what an inverse function, that is for inverse function, that is or for every x, it is what? If we solve this x for y, then we get x is equal to what? 5y minus 3 divided by 2. So for if we take any y, there exists x, real number x, such that f of x is equal to y, and therefore the given function is surjective. Surjective, since it is surjective, therefore this is not correct option again. This is not a correct option, and therefore f is injective and surjective, therefore it is what? Bijective. So the correct option is what? Option number C. Now the next example, let f is a function from real number set R to minus 1 to 1, and g is a function from a real number set R to real number set R, defined as f of x is equal to sin x, and g of x is equal to x plus 1, then the composition g of f is number A, that is option A, not defined, B, it is equal to range of GOF is equal to 2, GOF is injective, and number D, GOF is bijective. Now first of all, g of f of x is equal to g of f of x is equal to g of f of x. So the codomain of f should be the domain for g. So what is the codomain for f? It is minus 1 to 1, and it should be a domain for g, but this is not true, and therefore the composition function GOF is not defined. So it is what? Not defined. So the correct option is what? A. Again, if we take the next example, let f is a function from a real number set R to minus 1 to 1, and g of x is equal to x plus 1, where g is a function from real number set R to R, and f of x is equal to sin x, then the composition function, f of g is surjective. First option is surjective. Option number B, injective. Option number C, bijective, and option number D, none. So the f is a function from first of all we are going to check whether this composition function is exist. F of g x is equal to f of g of x. So the codomain of g should be a domain of f. So what is the codomain of g? It is R, and it is what? Domain of f, and therefore the composition function is defined. And what is its function? It is equal to f of g of x. What is g of x? G of x is equal to x plus 1. And what is f of x plus 1? It is sine of x plus 1. So now I want to check whether it is surjective. Obviously it is not a surjective function. Why? because now G is a mapping from real number set to real number set, and F is a mapping from a real number set to minus 1, so 1 to 1, and therefore FOG is a function from a real number set to minus 1 to 1. So it is not an it is what it is not injective function. So sorry, this is not injective because here the whole set real number set is mapping to minus 1 to 1, so this is not an injective set. Next here it is not injective. Again see, therefore it is not bijective. Again, for every minus 1 the set lie between minus every elements from minus 1 to 1, there exists pre-image under this mapping, and therefore it is what? Surjective function. The correct option is what? Surjective.